So welcome. This session we discuss the solution of the CAT. The first question is to show that the convolution of the function f and g is the same as the convolution of the function g and f, where f is given by 2t and g is given by t cubed. So this really to provide a proof that the convolution operator is commutative, but then with the specific example of functions f and g. This was how to supposed to respond to this. Now, so we have the functions f of t given by 2t, and then g of t given by t cubed. So the question is to show that convolution of f and g is the same as convolution of g and f. So the first thing we have to remember the definition of convolution of two functions f and g. So case one, convolution of f and g, by definition, this is given by the integral from 0 to t f of t minus v times g of v dv. So given that the function f of t is 2t, then this implies that f of t minus v is the same as 2 into t minus v, which is the same as 2t minus 2v. And g of t is given by t cubed, so which means g of v will be given by v cubed. So therefore, this implies that convolution of f and g will be given by the integral from 0 to t. Now, where there's f of t minus v, we replace by 2t minus 2v. And then g of v is v cubed dv. Now, this is the same as integral from 0 to t. Opening the brackets, we'll have 2t v power 3 minus 2v power 4. Integration with respect to v. Now, this can be written as, you see 2 is common, so we can factor out 2. Integral from 0 to t v power 3 minus v power 4. Integration with respect to v. Now, integrating each term with respect to v, we'll have 2 into t v power 4 divided by 4 minus v power 5 divided by 5. And remember, these limits 0 to t are for v, so I have v from 0 to v equals to t. So putting in the upper limit, we'll have 2 into, so where there's v put t, so we'll have t times t power 4, which is t power 5 over 4 minus t power 5 over 5. And then lower limit, when you put where there's v by 0, everything will be 0. So this will be twice into, now a quarter minus a fifth, we get 1 over 20. So we'll have t power 5 over 20 And then when we multiply by 2, we get 1/10 times t power 5, or simply t power 5/10. So this is the solution for the convolution of f and g. Now, case 2, let's see the reverse process, convolution of g and f. By definition, this will be given by integral from 0 to t, g of t minus v times f of v dv. Now, given that g of t is t power 3, then this means g of t minus v will be given by t minus v power 3, which is the same thing as t power 3 using binomial expansion minus 3t squared v plus 3t v squared, and then minus v power 3. And then f of t is given by 2t, which implies f of v will be given by 2v. So this means convolution of f, g and f is integral from 0 to t. And then we have t minus v cubed multiplied by 2v, which is the f of v dv, which is the same as integral from 0 to t, and then t power 3 minus 3t squared v plus 3tv squared minus v power 3 we multiply by 2v dv. And next we'll get, we can factor out 2 because it's a common factor. So 2 integral from 0 to t, and then t power 3 multiplied by v, so t power 3v minus 3t squared. Now this v times this v, we get v squared plus 3t v power 3 minus v times v power 3 is v power 4. Integration is with respect to v. So this would be 2. Integral of this term with respect to v will be t power 3 v power 2 divided by 2 minus, now we'll have 3t squared v power 3 divided by 3 plus 3t v power 4 over 4 minus v power 5 divided by 5, and then limits v from 0 to v equals to t. Now what we are sure is that the lower limit will be 0 because every term has a v. So the answer will be 2 into, when you put v for t in this term, we get t cubed times t power 2, which is t power 5. So we'll have t power 5 over 2. And then next will be 3 and 3 cancels out, so we'll have just t power 5 plus 3 over 4 t power 5, because we'll have t power 4 times t minus t power 5 over 5. So inside the brackets, we have a half, and then minus 1 plus 3 over 4, and then minus 1 over 5. That gives us 1/20 t power 5. We'll have 2 times t power 5 over 20, which is still t power 5 over 10. So this is the convolution of g and f. And you see the same solution, t power 5 over 10, was obtained for f convoluted with G. So therefore, clearly we can see that convolution of F and G is the same as G convoluted with F, which is the same as T power 5 over 10. So we have successfully shown that the convolution of the function F and G, when F is 2t and G is t cubed, will give the same solution, whether we start by F followed by G or G followed by F. So that's what you're supposed to do. Thank you.